All right, day 3, we survived completing the square yesterday, so we're going to start with one that's a little on the tricky side just to make sure we're good to go. So I have an equation in standard form, y equals negative 3x squared plus 12x plus 5, and I want it in vertex form. I don't know how that happened. So if I want it in vertex form, I want it as y equals ax minus h squared plus k. That's my goal. First thing I see on this particular example is that it has a negative 3 at the beginning, and I don't like it. It's ugly. So I am going to factor out the negative 3. But if I may suggest a strategy, the first two terms I could divide negative 3 out quite nicely. But that 5 is going to be ugly. So I'm going to not do that to the 5. So watch for a second. I'm going to factor out the negative 3. I'm going to leave the plus 5, and I'm going to deal with him completely later. So when I factor that out, I have x squared as my first term, negative, because negative times negative is positive, and I need a 4x. So that if I were to do distributive law, I got what I started with. Okay, so I factored out the negative 3. Now I get to complete the square on what's in the bracket. So here's my thought process. My goal is to have x add or subtract a number squared. It's always half of that middle term. So if I'm completing the square on the x squared subtract 4x bit, then my goal is x subtract 2 squared. So that means I need to introduce a number into my equation, and the number that I'm going to introduce, sometimes I call it a magic number, but that's not very mathy. I'm going to introduce the number 4, and I'm going to add 4 and subtract 4 at the same time. So my second line will be, see if I can fit this all on here, y equals negative 3 x squared subtract 4x. I'm going to introduce a plus 4 and a subtract 4. I'm leaving my 5 till way later. The reason I introduced that positive 4 is that I know I want to be able to write the first 3 terms in the brackets as x subtract 2 squared. So y equals, here we go, negative 3 x subtract 2 squared. I still have, that took the first 3 terms, I still have the subtract 4. Almost done. I don't like that extra set of brackets because I want it in vertex form, and vertex form doesn't have that set of brackets, so I'm going to do distributive law. That would be the last thing I'm doing here. Sorry, I've missed my number 3 and 4. So the last thing I would do would be to do distributive law. Y equals negative 3 bracket x subtract 2 squared. Negative 3 times negative 4 is positive 12. And then I'm going to deal with the 5. He was just too ugly. So y equals negative 3 x subtract 2 squared plus 17. So my vertex is 2, 17. Okay. We're going to use completing the square to write this one in vertex form. We're going to do the same thing. I know that I want to factor out that 4 to start with so that I can complete the square on something simpler. But 4 doesn't divide into 3 very nicely, so I'm going to leave that plus 3 for later. When I factored out 4 from the first 2 terms, I have x squared plus 2x. When I complete the square, my process is to skip a line. So I've still got that 4. Skip a line and write x plus what? Squared, always half of the middle term. In order to get that beautiful perfect square, I'm going to go back up to the line before and introduce a number, both adding it and subtracting it to the equation so that it doesn't change the equation. The number that I'm introducing is 4, and subtract 4. Don't forget the 3. Okay, let's finish up that last line there. 4 x plus 2 squared, that takes care of the first 3 terms, but I still have that subtract 4. Don't forget the add 3. Almost there. I have an extra set of brackets. I have to because I factored out that 4 at the beginning. So as soon as you have to factor something out, you have an a that's more interesting than 1, then you're going to have a lot longer process. I'm going to do distributive law now with the 4 to get rid of that extra set of brackets. So I have 4 x plus 2 squared. 4 times negative 4 is negative 16. Don't forget the plus 3. And last line, I have the look that I want, vertex form. If I put those two numbers together, collect them and write negative 13. My vertex is 2 to the left, 13 down. And we have, okay, thought we had another completing the square, but we don't. The discriminant. Discriminant. Apparently I can't spell. I apologize for that. Discriminant comes from the word discrimination. It helps you to discern things. Okay, differences between things. How many x-intercepts can a parabola have? Well, we know that you could have 2 x-intercepts if your parabola opens upwards and has a vertex below the x-axis, or if your parabola opens downwards and is above the x-axis. You can have 1 x-intercept if your parabola lies on the x-axis, either upwards or downwards. It is also possible to have no x-intercepts. And that happens if you have one that opens downwards with a vertex below the x-axis, and they're kind of floating here, and this one opens upwards above the x-axis. So it is possible to have any one of those 3 scenarios. Now here's another recall. We were able to find x-intercepts, so solve, find x-intercepts. So let me write the word find, just a second. Solve, find x-intercepts, or roots, or zeros. Remember, all the same thing. Sometimes things aren't nicely factorable, so we introduce the quadratic formula. So let's write it right in the middle. My x is equal to negative b, add or subtract, b squared minus 4ac over 2a. If your parabola is in standard form and you have an a value in front of the x squared term, a b value in front of the x term, and c value in front of the numeric term. So for these ones on this page, my a, b, and c value are nicely in order, and my a value is invisible 1 in both cases. So let's determine what the x-intercepts are for these 2 particular parabolas. 3 parabolas. I wondered about that. Here we go. For the first one, x is, and I've got to put the right numbers into the equation in the right spot. So if b is negative 8 in this particular example, then in my equation I put regular 8. Add or subtract, that gives me 2 possible x-intercepts, big old square root. First thing I want under the root sign is b squared. Negative 8 squared is positive 64. Subtract, and it says 4ac, so I want 4 times a is invisible 1. C is 12 over, and on the bottom, and that denominator is under the whole mess, the bottom is 2 times A, and A is invisible 1. So first thing I do is put all of the numbers in the right spot. I tend to do this work first. So b squared, whatever my b value is, I just square it and put it in there. All right. Line 2. X equals 8. Add or subtract. Let's figure out what's under the root sign. So it is 64. Subtract 4 times 1 times 12. Well, 4 times 1 is 4. That's easy. 4 times 12 is 48 over 2. All right, x, add or subtract. 64 subtract 48 is 16. Oh, this is going to be nice. Square root of 16 is a nice number. 8, add or subtract. Square root of 16 is the number 4. Okay. We don't always have to write all of these lines, but you do need to be able to do it correctly, so it never hurts. From this right here, I can write my 2 possible answers. X equals 8, add 4 over 2, or x equals 8, subtract 4 over 2. The first answer, 8 plus 4 is 12. 12 over 2 is 6. The second x-intercept would be 8 subtract 4 is 2. Is 4. 4 over 2 is 2. So the first parabola has 2 x-intercepts at both 6 and at 2. Let's do the second one. Want my x-intercepts. Boy, the numbers are awfully similar for this thing. The only thing that's different really is that 16. Okay, negative b. Well, my b value is negative 8, so negative b must be positive 8. Add or subtract, big old square root. Under the square root sign, I have b squared, and negative 8 squared means negative 8 times negative 8, so that's 64. Subtract 4 times a, invisible 1, times c, 16, over 2 times invisible 1. Okay, let's tidy up some numbers. 8, add or subtract. 64, subtract. 4 times 1 is 4. 4 times 16, where? 64 over 2. 8, add or subtract. 64 subtract 64 is 0 over 2. This one will only give us one answer. 8 plus 0 is 8 over 2 is 4. 8 subtract 0 is 8 over 2 is 4. This one only has one answer, or one x-intercept. This first one that we did has 2 x-intercepts. Right, let's have a look at the bottom here. Oh, interesting, similar numbers again. To find my x values, I'm going to use the quadratic formula. So negative b would be 8. Add or subtract, big old square root. B squared, 64, minus 4 times invisible 1 times c. I'm going a little faster because most of the numbers are the same. 2 times invisible 1. Next line, let's tidy up under the root sign. 8, add or subtract. 64. Subtract 4 times 1 is 4. 4 times 20 is 80 over 2. X equals 8, add or subtract. 64 subtract 80, negative 16. Oh no. If we type in square root, of a negative number onto our calculator, what's going to happen? It's going to swear at you. Calculator swear actually looks like error 1. But it's going to swear at you, and that means there is no answer, silly. There are no x-intercepts. So if you noticed, The only thing that was different with these three examples is what was under the square root sign. In the case where there were no x-intercepts, the root sign had a negative underneath it, and that was a problem. For the one that had two x-intercepts, there was a positive number under the root sign. And lastly, the one that only had one x-intercept had a 0 under the root sign. So we're going to put that information together and cheat a little bit. It says, without graphing, determine the number of x-intercepts. Well, I know the business under the root sign told me last time how many x-intercepts I had. So I'm going to just cheat and look at that part, and that should tell me how many x-intercepts I have. If under the root sign I have a 0, then I have one x-intercept. If under the root sign, so that b squared minus 4ac business, if it is greater than 0, then I should have two x-intercepts. And if b squared minus 4ac, or the business under the root sign, was negative, then I should have no x-intercepts. We call this the discriminant. All right. The first one, y equals 5x squared plus 3x minus 7. All I want to know is how many x-intercepts are there. So I'm going to look at b squared minus 4ac and see what I get. For this particular one, this is my a, this is my b, it's nicely in order for me, and this is my c in standard form. B squared would be 3 squared. Subtract 4 times a value is 5 times c. My c value is negative 7. So b squared minus 4ac equals 9. Subtract 4 times 5 times negative 7. So I have a negative and a negative, so I have a positive. 4 times 5 is 20. 20 times 7 is 140. 149 is definitely positive. I definitely have two x-intercepts. The second one, I'm going to look at b squared minus 4ac and see what I get. Okay, this one also is nicely ordered. The x squared term gives me my a value. The x term gives me my b value. It's invisible, negative 1. My c value is 3. So b squared is negative 1 squared, which is positive 1. 4 times a, which is 4 as well, times c, which is 3. So I have 1, and there's only one negative, so subtract. 4 times 4 is 16, times 3 is 48. That is definitely negative. I definitely have no x-intercepts. It's negative 47. Okay,